I'll share my screen. Okay, so we covered this idea. We cover a few things. Number one, we cover the concept called function template, and then we talk about the concept called pointer to function, and then we talk about how to mix these two concepts together to define the template and then use pointer to the function. So we're going to talk a few other things along the line, which I think for me. I cannot justify why we want to use some of the language construct defined by the C++, but nevertheless, I think we have to learn it because we have to understand somebody else's code. So along the line, the next one is called lambda expression. And after lambda expression, we're going to talk about something called class template. It's not just function template, but class. You can also have a template. And then finally, we look at the implementation of STD, the standard C++ library, which such as a vector, you will actually start to use a vector. And guess what vector is? Vector is a template class. So basically, vector or map, those are the most beautiful, most useful implementation. I mean, to use vector, you don't need to understand how template works, but the source code, the template that implement vector is actually there in your system. So that's why sometimes you will be able to see that how those code being implemented. So essentially, what you learn about language, especially language like C++, is very different from C. In C language, that you essentially just only know what's the function interface, you can use it, you can compile. But in C++, a lot of those are actually have the source code, at least the header file, that's actually available to you, that you need to read the code. So as a C programmer, you never need to do something called inheritance. But in C++ code, we have to do inheritance. When you inherit a piece of code, especially with or without virtual function, then sometimes you want to know the behavior of the parent class, which itself might be a template class. And then you have to understand a little bit deeper to make sure you fully understand a class that you're inheriting from. That's why I feel the most important thing about what we're doing here is for us to understand somebody else's code. Okay, the first question, what's your name? Dennis asked before I even started is I think this is an excellent question. Why do we want to have a pointer to function? So last time we talked about pointer to function. In fact, you might extend your question is why do we need to have pointer, right? I mean, why do we have a pointer at all? That is essentially a very legit question because Java decided to kill, or Python also. Pretty much everybody else abandoned the idea of pointer except C kind of stuck here. So let's go back to your question. Why do we need to have this concept called pointer to a function?
Is the example of functions now regular defined function to example of function?
So pointer, the concept, this is a language for a pointer or function, right? This is the way to declare. Let me give you some examples. So this is the way I will declare a parameter called fptr. That's actually your variable name. This is the way I define this as a pointer to a function. And this is the way how I assign the value, which I assign is in range. And then this is actually how to call that, right? So this is a concept called pointer or function. So so far you can see that I haven't used any template. I'm just using regular C code with the pointer or function. By the way, this is actually available even in C, not just C++. So a question to ask is, why do we want to have the concept called pointer function? It's a very advanced question. To be honest with you, this is, I like your question, Dennis, is because this question differentiates the difference between training and education. So in my opinion about a computer science education is that not only we know what we need to learn in terms of skill to solve a problem, but we actually know why we build a tool called pointer to a function, or build a tool called any kind of language. Yes, in the back. Right, that's actually a good thing, is that I think that's the thank you. What's your name? Jeanette. Jeanette actually offered a very good answer. There are multiple versions of this answer, by the way. That's but I like her answer. She's basically saying that we want to pass the function as an argument. In other words, my way of saying this extended is that sometimes the idea between the caller and the callee. So what is a caller? Caller is the one who is going to invoke a function. Callee is a function itself. So if I don't have if I don't have the notion of the function pointer or the equivalent, my binding between the caller and callee needs to be settled at compiler time. So now this leads to another question, is that I want to make sure you understand that at least in C programming, there is a compiler time, there is a runtime. So compiler time is basically the compiler or the system is only look at the source code you included to combine into executable. So if I don't have function or pointer, then essentially that binding is going to be static. Means that after the compiler time, I kind of no longer will be able to substitute or change the behavior. So of course, I can actually write 2 million different functions and basically using a lot of if then else statement. And for my program to decide which version of the function to call, that's actually possible, but my program will be humongously huge. But instead, we're actually using the concept called dynamically linking library. So we talk about LD flag, right? LD flag, for example, JSON, you need to do SS to libjson.a, libjson cpp.a, which allow you to link to the library about all the JSON function. But when you link the library, by the way, there are two ways to link it. One is called statically linking. The other one is called dynamically linking. With dynamically linking means that I can actually change the library. So I can have a new function that's being added to that, and such that you will be able to run a new piece of code, even though your program is already running for 5 days. So that's actually something which dynamic linking library or function pointer. And the other way to actually do that is that you can actually essentially input a segment of binary code as binary through the like a standard input output, like a scanf or fscanf. You can actually include that and store in the memory somewhere, and basically using the concept of function pointer to actually pointing to the beginning of that segment, and then you can start to execute. So function pointer is a concept that's very powerful. It usually indicates dynamics, flexibility, but it also indicates a lot of potential vulnerability, because essentially that way you didn't have the compiler to safeguard the code itself. So the compiler and runtime support has to trust the piece of binary that you're going to pointing at a function or pointer. Okay, that hopefully give you some idea about why we need to have that. So let me actually show you a piece of code about, since you asked this question, I'm going to show you this piece of code first. let me see, which piece of code is a function pointer? Template. Okay, so I want to tell you that this is a piece of code we talked about. This line here, you see that this is the code I showed you earlier that you can actually define a variable called func_ptr, and you can choose any name. And if you define this, that means that this func_ptr is a pointer to a function with the taking one parameter, and that parameter's type is double, and then the return type is a Boolean value. Okay, that's the way you define. But you can do type define as well. If you don't like this, you can actually do this. This is actually interesting. Not too many people actually ever learn how to do this, but I found this is much more readable. So I define a type called function pointer type. So in C or C++, if you see a type of _t, usually that means it's a type. So essentially what I did is I define a type called func pointer type. And the thing is, you see that what I define is the keyword is type define bool, and then using exactly the same way like a function, a pointer to function with a parenthesis star about the name of the type. And then with the input parameter, that's one of them, which is a double. And that actually define func type. And then over here, you see that I just, when I define a function pointer, I just write a piece of code, looks like this. func_ptr t with func pointer. So these two are basically the same, equivalent. This one is just declare a function pointer without a type define. And this one, it looks more readable because this sometimes actually for a lot of us, it's harder to parse in terms of, oh, this is a declaration of a variable, which the variable is not at the end of the line, it's in the middle. So how do you actually take that out? Not very easy. But if I actually do type define, and then I write the code looks like this, func_ptrt, and with func pointer, this somewhat easier to read in terms of the code if you're going to do declare a lot of function pointer. And of course, that function pointer is one key element when you do what we call virtual function in C++. In fact, the way virtual function works is all leverage function pointer. Okay. All right. Any questions? So by the way, this piece of code, I haven't actually uploaded to GitHub, but I will upload all the segments. I have a lot of small segment code I would like to show you today. Okay, so this is one of them is related to how do you handle. And okay, since I'm here, let's actually take a look at this piece of code. So this piece of code is, I'm actually using both pointer to function and function template together. So this part is a function template. This part is function template, and this part is the type define for that pointer. So let's take a look at the function template again. Just refresh what you have. Is that template? This is the introducer that you actually have defined that what kind of type, what kind of variable you're going to use within the function, and then this is really the way you actually define the body of the template, which has the return type, has the name of the template, and then also with the input argument and then the code as well. So basically, this type name T is going to be, which means that when you use this template, you're going to provide 3 arguments within this smaller than and greater than. The first one is type name for T, the second one is upper bound, the third one is a lower bound. So it's actually provide you a template for you to create a lot of function very nicely. Okay, so as an example, you can see here, I'm actually using function pointer and template together, this line. So this line, I already declare FUNC PTR as a pointer to function. And then what I did is that I used that function template. I said is in range, but then remember with the three things. The first thing is double, and then 500 and 0. 500 correspond to upper, which is going to be replaced over here. This is going to be 500. This is going to be 0. And that is going to be the function, is whether it's in range. So, and the types is the double. So that's why after I instantiate, so after I do this, essentially I generate the code. By the way, this piece of code is generated at the compiler time, not runtime. This is actually compiler time concept. So this is compiler time, and then it will actually really create a function, and then with this parameter, and then really create as a function, and then assign the pointer of the function into the func PTR. Okay, and then how you call it? To call it is just looks like this. This is the way we call a function pointer, which is you put the function pointer, put a star, means you want to dereference that pointer. Dereference pointer, if that pointer is a regular data, you're going to get the data. But if that pointer is a function, when you dereference, that means you're going to call that function. So that's a little bit confusing. Okay, so reference a pointer, depending on what kind of pointer it is, you could either access the data or you actually call the function, depending on that. So because this is a pointer to function, when you dereference the pointer, it means you call it. And then the parameter is going to be whatever number you put it in. And then this is a perfect code for doing that. Yes.
Okay, so we have a pointer that points to a function. The function takes the double input of double.
Right.
What if I want a pointer that points to template function? It doesn't have to be double, it could be anything the user defines, it could be double integer, upload. Is that
okay
possible?
Okay. Let me try to understand your question because I could misunderstood. There is something called lambda expression. We might be able to do some of things like that. But in general, if sometimes you want the function pointer to pointing to a function that handle multiple types, that's one thing. Or you want the function pointer to be at runtime, that's actually, you bind it to a particular version of the function. That's two different things, right?
Just to handle multiple types. Just like when you have
a
function.
If I have a multiple type, if I want to handle multiple type, I have two places I can handle it. One, I can handle it in the template itself. I can handle it in the template. So in the template, I actually have a type, which is the parent of all the subclasses. So I can actually handle multiple types, right? Well, the other thing which I think you're getting at is that I might have a different template or different instantiation. For example, is in range, this way I put double, and then next time I put something else, right?
Exactly.
Yeah. I hesitate a little bit because I have to write enough code to do that, but I don't think that will be possible. Let me tell you why. Because the template need to be resolved at compiler time. So essentially, the template is a compiler time concept, is not a runtime concept, which means that I have some flexibility at runtime. But the thing in terms of the code, because think about this, I need to actually convert that piece of code into a compilable code in C++. And therefore, the C++ compiler, if they don't know the type of the function signature, they won't be able to compile, unless you write a function that doesn't require a type. So think about function template. Function template is really a compiler type concept. Really is a compiler, so you have to resolve that type. You cannot wait until the runtime. There are programming language that's actually allow that concept to even extend it to runtime, but then it will be a lot costly because which means that you're going to sacrifice your runtime performance. But by the way, to talk about this is that in C++, we try to put as much into the compiler time as possible, and that really try to boost its performance for compiler optimization. Yeah. Okay, but excellent question. I like your question. Any other question about the concept between point to the function and the function template? Okay. All right. So now, yes, please. Okay. So let me say that this part is the template. This part is a template. Let's look at this. Let me make it a little bit bigger. Okay. So this 4 or 5 lines I highlight is called a template. So it's a generic way to describe a common structure for a set of functions. But then it allowed me to write the code to, at compiler time, before compiler time, I can actually generate a lot of different code. So for example, let me use this example. So all of you have used this data structure called array, right? You have all used the data structure array. So when you use an array, usually you have to be very specific about what's the type of the array. It's array of integer, array of object, array of person. Well, C++ have a template, which you will see, it's called vector. And the vector, in fact, is a template which allow you to, using the same common structure for all the array, but you can actually say it's a vector of thing, vector of integer. So it's actually, you can use a vector for handle all kind of objects with a single construct. So that's kind of template. You kind of try to summarize. So let's actually take a look at this 5 line. So what this template is trying to do is actually trying to do this function called is in range. So what is a concept is in range? I haven't said is in range is double, is blood pressure, or is my GPA score. I didn't say any of that, all right? But I'm actually saying that, okay, is in range is going to return a Boolean function. It's true or false, okay? So that is a common part, Boolean. But it also say I have to input a parameter. This is my testing subject. I want to test this subject is actually within the range. Okay, so for example, I say whether this number is within the range of this 2. So then there's 2 common structure. It's called upper and the lower. It's called upper and lower means that if it's in range, then this needs to be smaller than the upper and greater than the lower. Okay, so that is the common structure. So now I want to apply the same common structure to say whether a double, if the subject I'm testing is a double, or is a person object, or is a JD type, or is an integer. So I actually want to create a template to allow the programmer to use this template and specify exactly the rest of the information, which is not covered by the common structure. Okay, so basically I have the common part, I try to describe in template. The rest of them is being parameterized that you can actually do that. So in this case, you can see what's the information. When I call it, I provide 3 information. I provide the type, which is I want to in range for the double, and then I provide this 2 value, the upper and the lower value to do that. Okay, that's the idea of a function. Does that answer your question? Okay, good. Any other question about function template? All right, so I want to actually show you something which is more complicated than this. If you understand, everybody feel comfortable about this. Now I'm going to move to a different example, which will introduce us to what we call lambda calculus. Not lambda calculus, lambda expression. I have to be careful about this. Hold on, why my window is gone? All right, let me actually make it smaller. Okay, I'm going to ask you about, take a look at this code. Is this the code I want to show you? No, this is not the code I want to show you. Just show you which piece first. Is that CT? No, that is one. I have too many code. I kind of, not this one. Where did I put the code? Oh, that's not good. Let me go back. It's probably in lambda example. Let me actually go down. No, it's not here. LL2, I missed that. No, this is not what I want to. Oh, I'm sorry. I'm so sorry. I missed that piece of code. Oh, no, I didn't miss it. Okay. I think I got it. I think I got it. Okay. Yeah, it's in this piece, but I have to go a little bit. Okay. So I want you to take a look at this piece of code here, this line. Going to take a look at this line. By the way, this is also a function template. It's a function template. Anybody want to guess what that code is doing? Just this line. Yes. What? It goes to all the elements of the array and then what? If it's what? The number is even. Okay. In the back?
We can see the text is beginning and ending number.
Right. Right. Okay, thank you. So a little bit different. Thank you for both of you, the answer. That's both of you are absolutely correct. So that's good. That's good. I like that. So this code is actually saying that from the beginning to the end, and I want to check whether that number is an even number or not. Okay. And well, the thing is that it's interesting. How do you actually parse this code? How do you actually parse this code? So I know what's the name of the function. Let's actually think about this. I know some of you actually got it already. Some of you never saw this piece of code. It could be confusing because when I first look at the code, I got confused. And I don't know how to parse this code. So first I wanted to ask you is what is the function name in this piece of code?
Even,
What?
even count. Or count if.
Count if, okay. Even count is the parameter, and the function is called count if, right? How many arguments count if is taking? When you look at the code. By the way, I just want to know this code is actually compilable. It's absolutely correct. So the first time I look at this, I'm going to look at, gosh, this is a syntax error. How can you have this code? The syntax error, but it's not. All right. So can you tell me how many arguments that we have? Yes. Three. Okay. Which is the first one? Okay. Non-stop beginning is the first, right? What's the second one? Non-stop end. And what's the third argument? What is the function? Where's the function begin? Where's the function end? What's the name of that function?
This from the vector nums.
the function? No, this is the nums, right? Nums is the vector. This is the function vector, which is the class template, right? So I have the vector in. But this is the argument I'm okay, but this is the second argument I'm okay. And there is a third argument, but where is the range of the third argument? Where is the first character of the third, the third argument? Where is the last
Nums that
letter?
the first two arguments are the first two arguments are the range for the third argument.
Right. And how about the third argument? The third argument usually say, let me give you an example what I mean by third argument. And if I say,
Vector, right? The third argument.
okay, let me, yes. So you're right. Thank you. What's your name again? Kafir. Yeah, sometimes I feel I pronounce your name. That's what I'm asking. Thank you. So what he's saying is that the argument starting with this character, where's my highlight? And all the way to this character here. Let me actually just kill it this way. So the third argument, you should take a look at this. This is your first lambda expression if you've never seen this code. So starting from this character all the way to this character. So this part, let me actually just remove all the new line. You will see what I'm doing. So this is the third argument. The whole thing here is a third argument. I mean, that's probably a better way to actually present it. I kind of lay out it in looks like it's hard to visually confuse you, but if you actually see the code do like this is actually the third argument. And the third argument, if you take a look, similar to what we discussed about whether you can actually change the behavior, this is essentially what we call lambda expression. It's actually lambda expression is what we call a function without name. So I can actually put this as a function, and I can actually introduce as the third argument of the count if. All right, and that's called lambda expression. So let me actually tell you a little bit of lambda expression, then we will come back. Because count if, by the way, count if is the from the standard STD algorithm. So algorithm contain a lot of such function that's actually a template. By the way, count if is actually a template, which I will show you what it looks like first, and then we'll go back to that if we have time. Oh, wow, I'm actually really running out of time. So if you look at this, I actually essentially copy this code. This piece of code is actually count if, is actually on your system. That when you actually call count if or any of the function, is really just a template. And I basically include it in this code, which I will post it on GitHub. I just changed the name to count if ecs36b, so I know it's instead of using the standard algorithm, I'm actually using my own template. And this template is exactly the same, except I changed the name. And then when I call it, I just call count if ecs36b. So now this is using function template, class template, and then using lambda expression to actually, because the third argument of this template is actually a function without a name. So let me actually get back to this concept, and then I like to stop earlier so we can actually talk about the midterm. So this is basically what we're talking about in chapter 9 of your textbook called lambda expression. It's a nameless function, is very useful when you want to pass a function as argument. So what's the other option? The other option is going to be function pointer. Over here, I can actually pass a lambda expression. It's the same as a function. For example, in this code, I actually define a lambda expression. I call the IIR. And you can see that this is what we call the lambda introducer. That means that if you see two brackets over there, right after the assignment or right after that, I know that is actually a lambda expression. And you can see that I have what we call the input type and then return type, and then with the function. So I'm actually using lambda expression to do is in range. Right now, this is a way to do that. And then I'm actually just call that lambda expression using IR with 35.5, 35.0. And that's exactly the way using lambda expression way of expressing exactly the same concept. I mean, which way you prefer, I don't know. But I definitely think that lambda expression, we should use it carefully because it's not so readable, because it's untraditional to the type you arrange. But in a lot of the standard C++ library, they actually use both template. They use lambda expression here and there. So here is how you are going to parse the lambda expression. Let me actually just stop after this slide. So here is a syntax of a lambda expression. So this is an introducer when you have a bracket. By the way, you can put stuff inside the bracket. I kind of will not go through the detail, at least today. And then you have this, looks like it's a pointer sign, but before the pointer, see, this is actually confused me. As a C programmer, every time I saw this, I thought it's a pointer. But in lambda expression, it's not a pointer. Lambda expression, this means that this is the input argument type, parameter type. This is the return type. That's another thing. Usually when we define function, we go return type first, then function name, and then input type. But over here is kind of reverse, become the input type, argument and the type, and the return type. And then between this bracket is whatever the body of the function. By the way, you can put 2 million lines of code between that pair of bracket. Is still considered one single lambda expression. Okay? I mean, I haven't seen anybody writing that kind of code, which is unnecessary. Okay, so that's the way we describe the introducer, the argument, the return type, and the function body. That's the lambda expression. And why we use that? I mean, Dennis, you asked a question. You can repeat your question again. As why do we want to have a lambda expression? If you ask me, I would say your instructor ecs36b has a very weak defense about why we need to do that. Okay, but anyway. All right, so any question about what we talk about? We actually expose ourselves to a lot of new concept. To many of you, I know some of you probably already got exposed into this concept. It's kind of, let me actually show you a piece of code, which is, I want to just tell you why you need to learn this, because I think you should know this. So I'm going to talk about a concept called vector. And guess what is a vector? Vector is a template. And let me show you the piece of code of a vector. So this is the source code of a vector. Let me actually make it a little bit bigger. This is the source code of the vector. And you can see here is a template, and then they define a vector. And inside this vector, they actually define a lot of function that you can access, iterator, constant iterator, and all this function that associated with the vector. So when you talk about vector, usually we can just pick the simplest way to use a vector. But if you really want to know the detail about the vector, that is indeed, it's just another big piece of C++ code and being encapsulated in the template, class template interface, which I will continue this subject after midterm. And the thing is that it's actually quite amazing. You learned a lot as well, but as a beginner, that I think if you can just understand that these things exist, whatever we use in this class or in the future, they're not just there by itself. They actually have a lot of source code to support that. And for you to gradually dive into that, if you're more interested in some of the advanced programming topic, that this actually gives you a lot of insight about how a programming language is being implemented, such as object-oriented. I remember when I was first time I learned C++, I actually traced the code about virtual function, how virtual function got implemented. By the way, I should actually give you a option. When you do compiler, you do G++, let me actually say that. If you do, say you do a G++ compiler, and usually you can put -C option, which is allow you to stop compiler. Many of you didn't know, you can actually do -E, capital E. So capital E will stop your compiler right after preprocessor. So you can see that if I do this, you can see I'm actually, the code looks a little bit different, but let me see. Is this a good example? You can see that this is, if you type -E, it's still a C program, but I don't have any like include statement because all the include statement has been replaced, has been done. And then this actually helps you to do a lot of debugging about what kind of code really got integrated into the code you just wrote, because you write so many include statement, what kind of things are inside. And using capital E flag is helping you to access to that level of information. Okay, I'm going to stop here and then let me